Hi everybody, and welcome to my second part of video about Powershell and DnSpy tricks in .NET reversing, especially AgentTesla. If you missed the first part, just check it. You can check it on YouTube, or you can check it on GitHub. On GitHub, basically, there is quite a simple guide. All scripts and all what I'm doing in the video is basically covered, but I don't want to repeat myself from the first part. So let's jump to the second part. Basically, in the second part, we will be analyzing final payload, AgentTesla, like reversing and deobfuscation. Basically, we will deobfuscate strings. We will deobfuscate some quite known obfuscator. It's an open source obfuscator, but the deobfuscation tool publicly will just quite don't work. So we'll be using default for some kind of custom string decryption, and also I will show you how you can do it in Python and PowerShell manually. In PowerShell, we will be basically invoking methods, and also we'll be initializing cctor, which is basically class constructor. I will show you how you can do it later. If you miss, again, the guide is quite simple on the GitHub. Every script I will be using in this video is basically covered in GitHub, and you can download it here. If you missed the references, just check it, because there are references about tools I will be using, and also about .NET internals information. So let's jump to our VM. Here is the final payload, basically AgentTesla. You can see again we will be using Take It Easy, and check it that it's written in .NET. And quite detected protector is Obfuscator. Obfuscator is basically some kind of open source obfuscator. There is one publicly available deobfuscator for Obfuscator, and it basically works like in the same way we will be doing manually with default and other things. So basically, you just don't want to use it. You just don't need to use it. For example, there are many obfuscator for which there is publicly none of free deobfuscators. So this, what I will show you, is basically working like in 99% of cases. So I hope it will show you some useful. Let's jump to DnSpy. And okay, let's put it here, final payload, and here you can see the entry point. Entry point is basically the main method, which is running at the start. But if you remember what I said in the first part of this video about .NET reversing and other stuffs, basically I said something that something is running before the main method, before the entry point. And this something is basically ctor or cctor, so class constructor and constructors. You can see here the main method, and you can see here that basically some strings are many strings, maybe probably all useful strings are some kind of encrypted or obfuscated. So as you remember, I told you something about class constructors, which basically runs before the main. And if you check it here, basically if DnSpy should show you, if you just check it here, that you can go to entry point, or somewhere here should be option go to cctor. There is not the option here. I don't know why, but it's not here. But if you check the classes, like for example class B, there is class constructor. If you check, for example, I don't know, again B, you can see class constructor. And if you check here the namespace, this one namespace and this one class, here is again class constructor. So if you jump back to the main and check where this the encryption method or decryption method for the strings are located, just jump to this method, and you can see something really strange. It looks like that every string is encoded with some kind of method, and these are only 3 values which basically are pushed as an parameters to the method. And if you jump to the method, you can see the 3 arguments. And basically, how does it work? You can see these 2 arguments are very important because it just basically served as indexes to some byte array, and this byte array is here, and you can see that this byte array is empty. It just has an empty name, but it doesn't mean anything. Yeah, it's just empty name, but it's not initiated. It's just empty. So where this byte variable will be populated, where and when. So basically, if you check the class constructor, what it does, you can basically see that this byte variable is populated in class constructor with many bytes. If you scroll a little down, you can see that it's trimmed because DnSpy is not showing all elements because this array is too big. This will be a problem later, but not for now. But what you can see here is basically the decryption of the bytes, which basically resolved in decrypted strings or character array. So when you just jump to the main, if you just break on the main method, these bytes will be already decoded somewhere in the memory, and you will see nicely readable strings, which basically get referenced. If you remember, they just get referenced by these 3 values. So there is more approach how you can decode strings manually with Powershell and Python. You can basically, in Python, you can just basically recreate this routine. You can just grab those bytes and recreate this routine. I will show you how you can do it later. With Powershell, there are more methods. I will show you two of them because I found it quite very interesting, and I hope that it will serve you as a simple trick. First one is basically that you can just, if you just go to CCTOR, if you are able to somehow get this variable, the field, the value of this field, if you just load the assembly via the reflection and get the type of class and get this field, when you are retrieving the field, basically what happened in the assembly, which is reflectively load, it just basically have to invoke the CCTOR, the class constructor, to respond you with the body of the byte of this variable, and this variable will be already populated not with these values, but already with the decoded values, because the constructor just invoke wall constructor and also all this decoded routine. So this is one approach, and the second approach is basically that you can invoke all of these methods. It's very simple because you can see that there are many of them, but if you check the first one, you can see that we can just basically invoke the methods via the metadata tokens, and if you check the tokens of the methods, they are like 22E, 22F, 230, 231, so basically it's increasing one by one, and the last one is just ending like 5 for something. It's just somewhere here. There are many of them, but you can see the last one is 542. So if we just manage to create the metadata tokens for all of these, something like range, and we will invoke them, you will just retrieve all the strings already decrypted. So this is the second approach in PowerShell. And in final stage of this video, I will show you how you can perform the decryption in default, because with these methods I already mentioned, like PowerShell and Python, you will just retrieve the decrypted strings. but we want to somehow modify the original sample, the original assembly. We want to basically, what we want to do is invoke all these methods. We want firstly get reference to all these methods, invoke them, retrieve the strings, and replace the locations from where these methods are referenced. Yep, and basically you can see something like this here. If we jump to main, I want to use the default in the final part of this video in the way that I want to basically, hey, delegate this method and retrieve the decrypted string and replace the decrypted string with this. So this original call for the decrypted methods, decryption methods will be replaced with the decrypted string. And that's basically what we want to know, what we want to get. After that, what we just do it, we can basically delete all namespace, which is responsible for the decryption. Yeah, all these things we can basically later delete, remove it from the assembly for the simplicity. And after that, you will basically get quite nice and readable AgentTesla code. So let's jump to the first approach in PowerShell, basically invoking the CC_TOR. So for this exercise, basically for this video, for this second part, I just created a few scripts which are available on my GitHub page. The link to the GitHub page will be available below this video, as always. So you can see the scripts here. There are two for PowerShell and one for Python. This last one is just basically for default I will show later. So first one is basically about invoking CC_TOR or initiating CC_TOR. You can see what we are doing here is basically very clear. We are just loading the assembly reflection, and here is the assembly object. You can see that I'm getting the type of class. You can see that the class is this one, which is basically responsible for the decryption routines. And why I'm getting the type of the class? Because in this class there are defined the fields which basically will have the value of the decoded bytes, like decoded characters, which we can join to big string already decrypted. You can see those field, what I mean, they are just in the end this one, the public static byte, empty name, and internal static byte and internal static string. But we are interested in the internal static string byte. If you check it, we are basically interested in this one. If we can somehow manage to get the field value, it will be already decrypted and we will see the decrypted string. So we're just getting type of the class, and you can see what I'm doing here. I'm basically saying, hey class, get me fields. The fields should be static and non-public. What does it mean? If you check it, it's defined as a internal static byte. So we just need a field which are static and not public. And for this, just give me only the field, because you can see that there are more fields like string and byte. I just need only this one. So you can see this, the token of the byte is variable byte is 4000198. If you check it here, this is basically the metadata token. So I'm just saying, hey, give me the field which is static and not public, and for this field which has metadata token equal to this value, get value of this field. And now basically the value is a character array already decrypted, but we want to join it to big string. What this is doing, basically when we have the field variable of type byte, which basically will contain all the decrypted bytes, and we are calling just get value. With this call to get value, we are just managing to initiating the cctor, which is basically just invoked, and run. The cctor will run, and you will retrieve already decrypted bytes, which will be joined. If you just run it, check it, and you can see that we just retrieved all the decrypted strings, and you can basically nicely guess what are all capabilities of this malware. Yeah, you can see some strings related to browsers and other stuffs and other stuffs and other stuffs. If you check it for here, basically you can see that there are many strings, but most of them are related to Chrome browser. So how you can retrieve this string in the memory? It's very simple. If you check, if you remember, I said you that the class constructor is running before the main. If you just put a breakpoint here, and there is another class constructor somewhere, maybe here. So put another breakpoint here, and now you can put a breakpoint to main, and you will see that the main is not running as a first method. Yep, it's always the constructors. And just run it. Okay. Nice. We can see that we just hit some, you can see the constructor in class B, namespace A. And you can see we are on the constructor. So let's continue, and we should hit the another one constructor. Yep. And where we are, if you check it here, we are in the constructor of the namespace private implementation and this class. So this is the decryption of the strings. If you continue, you will just finish on the main. You are on the breakpoint in the main, and what you can do to see the decrypted bytes, you can basically jump to memory view, and if you want to do it quickly, just basically check the strings here, and you can basically just find something like string and Chrome. No, this one no, this one no. Maybe there are more Chrome strings. Yep, and we are here. Now you can check it, that this is basically the decrypted strings. Nice. Okay, we can now stop it. I wanted to show you that what is cctor again, a little refresh and other things. But let's jump to the second approach from the PowerShell, and we just want to do one thing: invoke all the methods. As I already told you what I want to do, I want to invoke all these methods and retrieve all strings, not concatenating in like one big string, but they will be split, so it will be very it will be better and more readable. You can check it here, and we can run it. Oh, sorry for this. And we can run it, and you can see it here, invoking one by one method in this range of metadata tokens, and you can see the tokens are these from the first one to the last one. Simple. Yep. And you can see basically we just again loading the assembly, getting the type of the class, and from the class get methods where object metadata token are in this range, and module scope. It's important to specify the module scope, and we are invoking the functions. And what you can see here, nicely readable decrypted strings. Maybe probably better than the first solution. Now I wanted to show you how you can do it fully manually in Python. So here is the Python part, and you can see it here. It's very simple. You can see that basically we are just copying the method. We just grabbing these bytes, which are encrypted, and we are just replicating this decryption routine. If you check it here, it's quite simple. You can see that basically what it does, it just do something like, hey, do something for all bytes in this for all bytes, and for each byte basically encrypt this decrypt this byte with the value of the byte with current counter and with some hard-coded decimal value 170, and save it to the original position of the byte. And we're just doing the same here. Yep, counter and the current value of this byte array. And here is the current value, counter, and decimal value. And just decrypt it. If you run it, yep, and you can see basically that all strings are again decrypted. I probably prefer the second solution because the strings were nicely split. What I want to mention is basically what could be quite harder is how you can grab these bytes, because in DnSpy you can't just copy this, because you can see these bytes are trimmed, and I didn't find a workaround how you can see all the elements in DnSpy. You can go to edit IL instruction, but you just can't see it here, and you can copy that. So for this purpose, I will suggest you to use another tool, which is called ILSpy. And ILSpy is able, basically DnSpy is using ILSpy engine for the compilation, and I want to show you that ILSpy is able to give you these bytes. And I will show you how you can basically convert it to Python very simply and fast way. So ILSpy, here is the final payload. Just where it is? Yep, here. You can see here is the namespace and class for the decryption, and if you check it here, you will see it all. Come on. Okay. First of all, DnSpy also have Dark10. Yeah, maybe for some of you it will be quite nicer and more readable. But what I want to show you, if you just show the byte, the variable basically which just contains the encrypted bytes, you can just copy them, and you can just copy them all, because you can see they are not trimmed. Somewhere here it's ending, yep, and it's full. Here, copy, and we can very fastly just basically change the format to something for example Python, in Python format. Now here, and we can do something like replace, find and replace all spaces, replace all new lines, and replace. Also, you can see it's probably, what is this? Yeah, it's probably tabulators. So again, extend it. Yep. And tabulators are this. Okay. Now what you can do is basically replace comma and replace comma for space. And now you can do basically just from decimal, from decimal, and now you can just do 2 hex. 2 hex, and converted it like this. And now we can basically just copy that, copy raw, and paste it to Python. And okay, so this was for converting and retrieving the bytes. So if one tool just doesn't work, just try another one. DnSpy is, by the way, very good tool. Also, the Reflexil plugin for DnSpy is very useful. I will highly suggest you the Reflexil plugin for DnSpy because it can basically very nicely edit the original assembly in a different way than DnSpy. So that was all in DnSpy. Okay. Now we can basically jump to the default, because as I already told you, what we want to get is basically get rid of these methods, all the namespace, all the decryption class, and we want to basically have nicely readable code. In the main, we want to just get only the strings and not these method calls for decryption of strings. So how we can do it in quite a nicely way, just go to default folder. I have it somewhere here, .NET deobfuscator, default, and here is default. Now grab the original, for example, final payload here, final payload, run the default. Be careful because I think that cmd exe, like command line, is trimming the command arguments. PowerShell is more flexible for that, so just use PowerShell because we will have very long command line. I will show you. And what is basically the very big advantage of d4 is basically if you run d4 there is an option. You can see there is an option here, somewhere here. Somewhere here. Yep. String decryptor type, string decryptor method. These are basically features created basically for unknown obfuscators. D4 knows very many obfuscators and can be very helpful to deobfuscate them, but in many situations there is obfuscator which is not known. So in these cases you can basically find if you have decrypted all the strings, it's very powerful, and you just basically will find out what the malware code is doing. So you can see here is the string type, which is basically string decryptor type. There is, I think, static, delegate method, delegate type, and emulate. Basically, you should use the delegate method, and only if the malware code is detecting the delegation, so like dynamically invoking the methods, you have to use the emulate type. But for our purpose, we will just use a delegate type. And string token is basically the token of the methods we want to invoke and replace. So these are basically these tokens. Yep, these. So we just need a command line like this. d4. You can see here nice example in the last line. String type will be delegate, and string token, and what is very funny, because we just need all of these string tokens. So how we can do it, I already prepared a nice script in Python, very simple one. You can see it here, somewhere here. Generate tokens for d4. Python script for generation of tokens to deobfuscate final payload via d4. Yeah, that's it. What it basically does, okay, I will load it again because the terminal is quite chatty. So downloads, and again to here. And what I want to show you basically that we can use this one. Simple Python code. You can see that for I in range, and this is basically the range of the metadata token. Here's 543 because it's the ending. The last one is 542, and you can see that basically the first one is like ending with 22E, and you can see 22E, and the last one is 542. So this will generate the values for in this range, and you can see that I'm just basically creating the command with string token, string token, string token. You can see it here. I will just create the file because printing to terminal will just change the format, and I don't want it. So this is not the right path. So just copy path from here, replace this one, like this, and run it. Run it. You will see basically what the output looks like in terminal, but also I will create a new file which will not suffer with the strange formatting. And you can see it here, very, very, very long. And this is basically our command line option in 44. So just go to the location where we create new file, and you can see the it's somewhere here, tokens, and if you check it, nice. And what you just need to do, I know that really looks like some very, very different way. You can basically do something like using a DnLib and assembly resolver and other things. Basically, I think probably more DnLib, and do some universal obfuscator for this kind of obfuscator. But if you just if you are dealing with many kind of different .NET assembly obfuscated with different obfuscator, if you should be like up to date with all update for all kind of obfuscator, you just can't create a tool for everything to automate it. So just copy that and paste it to here like this. Yeah, it's very, very, very long command line because there are many, many metadata tokens. Yep. And after we reach the end, and you can see that it's absolutely okay for PowerShell, but command line cmd.exe will just trim you. Come on, come on. Yep, and that's it. And now just run it. Okay, something missing input file. Okay, so basically once again, and just jump to here, and here we should just basically edit the payload, the final payload file. Wow, final payload. Yep, and press it. Run it. You can see that basically it delegate and invoke all these methods, or replace them and do some cleanings and other things. Nice. What we just have here, we can check it. We can just close this one because we don't need it anymore. Close this one, close this one. File close. And here somewhere is the clean one. Here. Okay, okay, let's check it in DnSpy. Okay, put it here. Come on. And what you can see here in the main, you just take a while, that all the method which basically serve for the decryption of the strings are replaced with already decrypted strings. Nice. So the code is readable, and you can see here is the persistence, and everything is clear. This is basically some kind of rename methods. It's basically you can do anything with that. This is basically already deobfuscated because this is the namespace name. You just don't know the original namespace name. You just don't know the original class name, and you just don't know the original method name. Just replaced with the obfuscator. But if you jump to the method, it's already nicely readable code. But what we can do next is basically we already have all this replaced. We just don't need this whole namespace with all these methods because they are not used anymore. Already everything is already decrypted. So what you can do, right click and delete namespace. Nice. What you can do now, basically file and save. Save module. And we can save it. Okay, file. And we can again close it. And if you load it again, you can see basically if you jump to the entry point, you can see that the file is smaller, far smaller, and it's because the namespace is removed. You can't see here any namespace different than the A. And if you just jump back to the main, you can see it here, nicely readable code. And the best thing is basically that even though we really modify this original assembly, if we just put a breakpoint here, you can just debug it. You can just debug it as normal, as usual. Okay, and we are here. If we, for example, jump to somewhere, I don't know, for example, to this method, it's just doing some sleep, I think. Yep. You can just do like step over, this will just sleep, and continue to the end. Whatever you want, dynamic approach is very welcome every time. Nice. You can see many interesting things. Basically, you can find now, you can search for strings in this way and other things. What is very nice, if you just I want to share with you one fast tip. Basically, if you just grab, we are cyber defenders. We are not offenders. We are not the red team. But if I'm doing in my free time, I don't care about it, and I'm quite interested in how I can basically stop the phishing campaign, basically spreading this kind of malware in a fast way. This malware is usually exfiltrating the information somehow, and usually they are performing to use now they are also using Discord, they are using Telegram, but many password stealers are using SMTP. So basically they are sending the exfiltrated data to some compromised mail to itself. Yeah, so if you try, for example, here to find SMTP, here is method, and basically what it retrieves the data, the data for exfiltration, and here you can see basically credentials. This SMTP client will send email to itself, like to this username, and with this password. These are basically credentials for the SMTP. Okay, so what you can do next? My very nice approach in my free time is basically just do a little OSINT. If you check the domain and use, for example, my very favorite tool like DNS dumpster and check it, you will find what you want to find. You can just you can use these credentials for IMAP and POP3 and other stuffs, but so you will be able to read the already received mails, but you will not be able to change the password for this compromised mail account, which is used for retrieving the exfiltrated data for all kinds of users. So how you can do it, you just need to find some web interface to manage this account. How you can do it, DNS dumpster, and if you check, we just found somewhere here is webmail mosaic.com mx, and if you check it, we are here. And if you just don't try to use this credential, because I analyzed this sample like 2 months ago, and I basically get this sample like 1 hour after that it was created, and I was able to stop the campaign spreading exactly this sample in very fast way. So if you check it, I already changed the credentials. I'm the owner, but I don't care about it. So basically, if I should report all guys who just get compromised the mails, it would just take me a lot of time. So basically, I will do it like this way. So I'm trying to stop the company in a fast way, and that's basically all. Now you have the sample, which you can still nicely debug. You can nicely read all the code, all the capabilities, all the things. If you need some guide, how you can write the report about capabilities and something like that, little snippet is on my GitHub page. You can see here in the start of the second part that here is some what the AgentTesla is stealing, this sample. What are the capabilities? Like, it's stealing FTP services credential more than 30 different web browsers. It's able to use deep API decryption because for example Chrome credentials and other things. Basically steals all kinds of credentials. Many nice methods are basically defined there, so you will learn a lot with reading the code. And capabilities are here. Basically read, backdoor, and stealer. That's all. And I think that's probably all what I wanted to cover here. So thank you for watching, and I hope you enjoyed it and learned some new tricks. See you next time.